An AI model built to think like a software engineer just dropped quietly. Windsurf's SWE1 is designed to handle real-world dev tasks, reviews, debugging, long-term maintenance, and incomplete work. And with reports of a $3 billion acquisition by OpenAI, this isn't just a product update, it could redefine how AI embeds into professional engineering workflows. In this video, we break down what SWE1 is, how it works, and why it's starting to reshape the conversation around AI in software development. Why current coding AIs don't cut it if you've used tools like GPT-4, Claude 3, 5 or Gemini 1. 5 Pro, you've seen how well they can generate boilerplate code or offer quick debugging. These models are powerful generalists, trained on diverse data across domains, and that's exactly where the limitation starts. Real-world software engineering isn't a one-shot prompt. Developers don't just write a function and move on. They jump between incomplete tasks, collaborate across teams, conduct code reviews, debug legacy systems, and track long-term dependencies. That workflow is dynamic, often fragmented, and requires long-term context. Something most general-purpose models lose quickly. Windsurf's product team noted this recurring issue through feedback from their users' developers, reported that current tools worked reasonably well in short bursts, but struggled over longer development cycles. The underlying reason: these models weren't built for engineering, they were retrofitted for it. So instead of tweaking an existing general-purpose LLM, Windsurf started from scratch. Their approach involved training models explicitly for software engineering workflows, with a focus on sequential decision-making, not just code prediction. That meant building models that could understand incomplete workspan across long-running tasks and maintain awareness of where a developer is in their project, not just what code they typed in that moment. This shift reflects a broader industry insight. The next generation of dev tools can't be autocomplete engines. They have to be collaborative systems aware of both code and context. SWE1 is Windsurf's answer to that challenge. Why Windsurf split SWE1 into 3 models? Unlike other AI offerings that rely on a single model to handle all tasks, Windsurf has introduced a 3-model system under the SWE1 umbrella, each built for a specific role in the engineering workflow. The flagship model, simply named SWE1, is the full-scale version. It's built for high-level reasoning, tool usage, and multi-step workflows. This is the model aimed at handling more complex tasks like long-form code reviews, architecture, reasoning, and integration planning, according to Windsurf. This version is currently available to paid users and was built to match and in certain tasks outperform existing mid-sized LLMs on software-specific benchmarks. Then there's SWE1 Lite, a smaller yet still capable model that replaces Windsurf's previous cascade-based model. It's available to both free and paid users, providing a more accessible option while still benefiting from the new training architecture. SWE1 Lite handles shorter, more immediate tasks like inline suggestions, refactoring assistance, or lightweight code completion. Finally, the SWE1 Mini model powers passive predictions within the Windsurf tab interface. It's designed to offer continuous, unobtrusive support during development, without demanding explicit prompts. This version is available for unlimited use by all users, and is optimized for speed and efficiency, rather than deep reasoning. What makes all 3 models different is their training foundation, instead of relying solely on open-source code or public repositories. Windsurf developed an in-house training method using sequential step-based data. This means the model wasn't just trained on code itself, but on the process of developing software. What happens before and after code is written, how tasks evolve, and where human decisions fit into the life cycle, by separating the models based on task complexity and user needs. Windsurf isn't offering a one-size-fits-all solution. Instead, they're building an AI system that mirrors the reality of modern software teams, where different tasks require different levels of assistance. What is flow awareness, and why it changes everything? One of SWE's most defining features is a concept Windsurf calls flow awareness. Unlike traditional coding tools that respond to prompts in isolation, SWE1 is designed to understand where a task fits within a developer's larger workflow, whether it's writing, reviewing, refactoring, or debugging. This is achieved through what Windsurf describes as a shared timeline between the developer and the AI. Instead of treating each request as a standalone task, the model tracks project context over time, recognizing how tasks evolve and how decisions made earlier affect what comes next in practice. This allows SWE1 to support more than just code generation. For example, it might flag inconsistencies during refactoring or suggest architectural changes based on earlier patterns. Because it retains awareness across long sessions, it's better suited for real-world development cycles that involve switching between incomplete tasks. This context retention is particularly valuable in enterprise settings, where engineers often move between features, bug fixes, and legacy code maintenance. SWE1's ability to track intent and sequence helps it remain relevant across different stages of a project rather than resetting each time a new prompt is issued. Windsurf has already integrated this functionality into tools like version control systems and issue trackers. The goal isn't to replace developers, but to support them continuously, offering timely contextual input as part of the workflow, not just as a response engine. Benchmarking SWE1 against the best when it comes to performance. SWE1 isn't aiming to compete head-to-head with the largest foundation models, like GPT-4, Claude 3.7 or Gemini 2.5 Pro I/O edition across every domain. Instead, Windsurf has positioned it within a more focused benchmark engineering-specific performance, according to internal evaluations shared by the company. SWE1 substantially outperforms mid-sized foundation models and many open-weight alternatives on tasks like multi-step debugging, code maintenance suggestions, and long context reasoning in engineering workflows. While exact metrics haven't been made public yet, the company has clarified that SWE1's performance is competitive with frontier-class models within the scope of software engineering. That said, Windsurf also emphasizes caution in a statement to VentureBeat head of product Anul Ramachandran acknowledged that even though SWE1 shows strong results, it's not objectively better than all the other models. The team's focus isn't on claiming superiority across the board, but on refining SWE1 to be more effective in long-term iterative engineering tasks that are typically underserved by general-purpose models. It's a practical stance instead of chasing raw benchmark scores. SWE1 is optimized for sustained collaboration over time with a focus on predictability, low latency, and relevance in software development environments. Another key differentiator is how SWE1 maintains contextual accuracy over extended workflows, which is critical for DVs working on large code bases. General purpose LLMs often lose thread consistency after a few interactions, forcing developers to reset or manually re-establish context. SWE1's flow awareness design, combined with its timeline architecture, is built to preserve that continuity across sessions for teams relying on LLMs not just for fast code generation, but for dependable engineering support over time. These workflow-specific advantages matter more than top-line benchmark performance. That's where SWE1 is beginning to carve out space. Why this matters for teams and tech leaders. Most engineering time isn't spent writing new code, it's spent managing what already exists. Teams regularly deal with testing, debugging, integration, and technical debt. While general-purpose AI tools can assist with isolated tasks, they often fall short in supporting the broader, messier workflows common in real-world development. SWE1 is designed to address this gap by operating across incomplete work states and maintaining awareness of project context. It aligns more closely with how developers actually work, switching between file staging commits and troubleshooting across systems. This makes it more adaptable to long-running iterative engineering tasks for technical leaders. The key consideration isn't just code generation speed, but how AI can reduce cognitive overhead across entire workflows. SWE's ability to embed within version control editors and collaborative tools allows it to assist continuously, not just reactively. It doesn't ask for prompts, it follows along. Currently, SWE1 integrates with Windsurf's browser ID, VS Code, and Git workflows. Future plans include support for issue tracking and CI/CD tools rather than acting as a surface-level chatbot. It's being positioned as an embedded system that supports engineering decisions in context. What happens if OpenAI finalizes the acquisition as of May 2025? OpenAI's reported acquisition of Windsurf has not been officially confirmed, but multiple credible sources, including The Information and VentureBeat, have stated that the deal is in progress and could be valued at up to $3 billion. If completed, it would represent one of the largest AI acquisitions of the year, signaling growing interest in domain-specific models that go beyond general-purpose applications. Integrating Windsurf into OpenAI's ecosystem would likely give SWE1 access to significantly more resources, including compute infrastructure, agent research, and advanced training pipelines. This could accelerate the development of SWE1 models and potentially expand their capabilities beyond what Windsurf could have scaled independently. It may also enable tighter integration with OpenAI's existing platforms such as ChatGPT Enterprise or Codex. The acquisition also fits into OpenAI's broader strategy around verticalized AI models tailored for specific professional tasks. SWE1, which is designed for the full spectrum of software engineering workflows, aligns closely with this direction. It's not a generalist language model, but a specialist aimed at long-term development processes like debugging, refactoring, and project maintenance. Whether SWE1 will remain a standalone product or be folded into OpenAI's existing tools remains to be seen. But if the deal goes through, it could mark a turning point in how AI is deployed in software teams, shifting from isolated code generation to embedded systems that support the full engineering lifecycle. The beginning of AI native engineering. The introduction of SWE1 reflects a larger trend in AI moving away from surface-level productivity gains and toward deeply embedded systems that understand workflows at a granular level instead of seeing AI as a tool to write a few lines of code faster. SWE1 treats it as a participant in the full software engineering lifecycle, aware of what has happened, what needs to happen next, and where automation can take over without losing fidelity. This approach doesn't just extend the capabilities of code assistance. It reframes how AI fits into the engineering process altogether, with flow awareness, timeline tracking, and model variants designed for task-specific assistance. SWE1 attempts to mirror how real software teams operate, not how prompts are typed into a chat window. And while general-purpose LLMs will continue to play a major role across disciplines, the rise of domain-native AI like SWE1 may signal a turning point where specialized models start outperforming generalists in real-world sustained high-context tasks, with OpenAI possibly entering the picture. This evolution could move faster than expected, but even without the acquisition, Windsurf's release of SWE1 adds new weight to the discussion around AI's role in structured professional environments, especially those involving legacy code long-term systems and collaborative decision-making for developers and technical leaders watching the space closely. SWE1 isn't just another tool. It's a signal of how AI may soon shift from helping write software to helping engineer it. If you've made it this far, let us know what you think in the comment section below for more interesting topics. Make sure you watch the recommended video that you see on the screen right now. Thanks for watching.